Hello, let's talk soils and weathering. We're going to begin with what is soil, and then we're going to go into all the different kinds of weathering. So soil, the definition of soil depends on who you ask. If you're asking a soil scientist, someone who studies soils for a living, they're going to have a different definition than say an engineer would have. So let's say a soil scientist thinks of the dirt that can support life. So check out the definition here. An engineer is going to see it a little differently. It's a soil scientist is going to think of it as any solid material that can be removed without blasting. So scooped up, scraped up, shoveled up, all of that is soil. So we might consider the term regolith that a soil scientist would use for everything that's loose on the outside of the earth that grows plants and also doesn't grow plants. So regolith is a good term there. It's unconsolidated, not lithified into rock material on the earth's surface. Another term we talk about in with soils is the pedosphere. And the pedosphere is that sphere of regolith outside of the lithosphere and under the atmosphere. And that is also a way we could talk about the organic matter and the inorganic matter that make up that layer surrounding the lithosphere. So lots of different ways we could look at what is soil. A little bit more about soil here. Soil has lots of organic material in it. Some of it is dead and decomposing, and some of it is totally alive. So a handful of soil, just one scoop, contains billions of little microbes, decomposing plant matter, decomposing animal matter, minerals that are decomposing, and general nutrients that are generated from the decomposition of organic material and inorganic material like rocks. There is that interconnectedness between the lithosphere, the hydrosphere, the atmosphere that occurs at the pedosphere along with the biosphere. So the biosphere is living within the pedosphere. There's air going in and out of the pedosphere. The pedosphere is sitting right on the lithosphere, and the hydrosphere is the water is percolating through that pedosphere. So all those spheres interact at the pedosphere. One of our most important activities in of humans do is grow food. At this point, if we were live in lecture, I would say, who is the most important person in your life? And we'd sit there a minute, and some of us would look at our boyfriends or girlfriends, or maybe we would think about our mom or our favorite grandfather. And really, the most important person to your life is a farmer because you have to eat. So I say that with a little smirk, but really a farmer is the most important person to your life. Okay, so that one of the most important activities we do is grow food. There is a great concern in modern society about the health of our soils. Maybe you compost or your family has composted in the past. Maybe you've tried to plant a tree just to decrease erosion or plant grass. But eroding topsoil and the conservation of soil and the health of soil is a very important concern worldwide. Okay, so let's think about that resource. Soil is interesting because it can be a pollutant if it gets into waterways, but also soil is one of our most important resources. Growing food, keeping that healthy soil. We have to have enough food to feed growing populations. We need to think about soil. This is what a soil scientist might do when we think about land use planning. One of the things is different soils are going to have different strengths, different porosities, different ways they should be handled with land use. And one big concern is always waste management. There are hazards associated with soil because it moves around, right, pretty easily. And we can use soil to map hazards. So if you look at soil on a floodplain, you can figure out where past floods, the height at which that flood got to, what was that discharge, what was that water level, what was the stage. We also use soils and mapping soils to think about past mass movement. That's just kind of a general term for things like landslides. And then I mentioned this before, that soil can degrade our water supply. If the topsoil washes off into water, it can harm the aquatic organisms, and especially if it gets to our ocean basins where it lands on top of corals, not good. All right, before we get into any more about soils, I want to step back and talk about the weathering of rocks. So if you spent much time in Boone and hiked off the beaten track, this is the top of Snake Mountain. That old pole was cemented into the ground, but it's not there anymore. And I show this image because we're talking about the weathering of rocks. This is a rock type called amphibolite. Amphibolite is foliated, it has that layering to it, and it preferentially erodes along these planes of weakness that are defined by the foliation. So that all these linear pits in here, that is erosion of the minerals within that amphibolite. So many rocks around here weather that way. Oh, my face is in the way. Over here. Okay, so we're altering rocks now. Physical, chemical, biological processes all can alter rocks at the Earth's surface. When we're altering the rock, we're altering the minerals. So rocks can be made out of one mineral or they can be made out of a variety of minerals, and we can weather and erode those individual minerals, thus breaking down the rock. Exposure at or near the Earth's surface to air, water, wind, acidic solutions, and biological phenomena. So that's the why. Like, why do we have this weathering of rocks? Why do rocks break down? They're out of equilibrium, and there are these the wind, water, acids, biological activity are all working against the preservation of those minerals or eating them away. A couple terms here. So weathering happens in place at the rock. Erosion is the movement, the removal of that whatever the product of weathering is, and then it's transported by wind, water, ice, driven by gravity. So here are two main types of weathering: the chemical weathering and physical weathering. So chemical weathering, you're having an alteration of rocks and minerals that's happening because of a chemical reaction. Physical weathering is the physical disintegration, that the rocks are going to disintegrate physically. There's usually some kind of mechanical fragmentation of the rocks or minerals. Both of those are made faster by biological activity. So we'll look at those separately.